Dear children, good afternoon. Welcome to the E-class of GPS. So, let us start the first lesson. But before going through the lesson, let me introduce you about the syllabus of mathematics. Here is the complete syllabus. You can see there are 6 units. First unit is a relation and functions. Under the 2 lessons are there: relation function and inverse trigonometry function, and its weightage is 8 marks. Then unit 2 algebra, it consists of 2 lessons: matrices and determinants. The weightage is 10 marks. And the most important unit, the calculus, which covers 35 marks, almost 50% of your total mark, that is of 80, and that consists of 5 lessons: this continuity and differentiability, application of derivative, integrals, application of integrals, differential equation, and unit 4, that is vector and 3D, consists of 2 lessons: vectors, 3D geometry, weightage is 14 marks. Then linear programming problem, LPP, the weightage is 5 marks, and probability, the weightage is 8 marks. So this is your syllabus. Let us move to our lesson, unit 1, chapter 1, that is relation and function. Okay, so already you have been acquainted with this chapter, relations and function, because you have studied already about the relation in class 11. Okay, just you recall, in class 11 you have studied about relation. What is a relation? Relation, it's a nothing but a connection between two objects. Okay, so that two objects, for example, let us take two sets: A, students of 12, B, students of 11. So I can construct a relation R, okay, with the ordered pair AB, such that A belongs to A and B belongs to set B, and A is the brother of B. Okay, so here I have taken a simple example. Students of class 12, that is set A, and students of class 11, that is set B. So there is a relation R between A and B, that is AB, the ordered pair. A belongs to set A and B belongs to set B. A is the brother of B. So we can get some relations between two students of class 12 and class 11. One of the student of class 11 may be the brother of the student of class 12. So that is a relation. And here set A, it is called as the domain. I am just recapitulating the class 11 syllabus. Then B is called as the codomain, and R are the relation which you are getting here. Okay, that relation, this is the range. So domain, codomain, range. And another important thing, R is always a subset of A cross B. And you might have known about the Cartesian product. This is the Cartesian product of two sets. Cartesian product of two sets, and the relation from A to B is always a subset of A cross B. So this is all about what you have studied in class 11. Now let us move to class 12 syllabus. Okay. So let us start with the definition of relation. A relation R in set A is the subset of A cross A. Okay, this is the definition of a relation. Types of relation. Types of relation. There are three types of relation. One is there are three types of relation. First one is empty relation. Empty relation. What is that? Now a relation R in A is said to be an empty relation if R is equal to phi. Phi is the empty set. That is, for example, let us take a set A 1 and 3. Okay, and R, I will take one relation AB such that AB belongs to A and A plus B is an odd number. Okay, so here the given set is 1 3. So R is the relation defined by AB such that AB belongs to set A and A plus B is an odd number. Now let us find out R. As R is a subset of A cross A, so here R is equal to, the ordered pairs will be 1 3, 1 1, 3 1 and 3 3. Okay, so it is defined as A plus B. A plus B, 1 plus 3 4, which is not an odd number, even number. 1 plus 1 2, even. 3 plus 1 4, even. 3 plus 3 6, even. So as per the relation how it is defined, here we are not getting any odd number. That means here R is equal to phi, because all these ordered pairs, they do not belong to this R defined by A plus B is an odd number. R is equal to phi. This is called as an empty relation. Sometimes it is also called as void relation. Void relation. Okay, this is the first type of relation. Then let's move to second type. Second one, that is universal relation. Universal relation. A relation R in A is said to be a universal relation when R is equal to A cross A. As I have said, the relation is always a subset of A cross A. But when the complete relation belongs to the complete ordered pair of A cross A, then it is said to be a universal relation. If I will cite the same example, that A is equal to 1, 3, and R I will define A, B such that AB belongs to A and A plus B is even. Okay, in that example I have taken that A plus B is odd. Now A plus B is even. So definitely here A cross A is equal to 1 3 3 1 1 1 and 3 3. Okay children, so here A cross A is equal to this one. Now in each case, if you will see 1 plus 3 or 3 plus 1 or 1 plus 1 or 3 plus 3, so in each case we are getting an even number. So here R is equal to A cross A as per this definition. Hence in this case R is said to be a universal relation. Is it clear? Now both empty relation and universal relation both of them are called as trivial relation. Okay, both empty relation and universal relation, they are called as trivial relation. Okay, now let us discuss about another type of relation, that is identity relation. Okay, don't worry, whatever I am writing in the whiteboard, the same screenshot I will send you, or that PDF file I will send you, you can make a notes. Okay, so identity relation, a relation R in A is said to be an identity relation when R is equal to A. I think it is not visible clearly. Relation when A belongs to R for all A belongs to A. That is, if A is given, for example A is given as 154. Okay, then R is a subset of A cross A, then A cross A. Let us think about three different types of relations. R1, one relation I am taking, any subset of A cross A. I am taking it as 1 5 1 4 1 1 1 1 5 5 and 4 4. Okay, as you know, there are three elements in set A. So A cross A, it has 3 into 3, 9 elements. So R is a subset of A cross A. Here I have taken 5 ordered pairs. Okay, just examples. R2, another relation, 1 1 5 5 1 4 and 5 4. Okay, and R3, 1 1 4 4 5 5. Okay, so here just go through R1 is a defined identity relation, said to be identity relation when A belongs to R. So here we have 1 1 5 5 and 4 4. Okay, so all the three are there in R1, hence it is an identity relation and it is written as IR, identity relation. R2, here you can see 1 1 and 5 5 is there, but 4 4 is not here. Okay, so this is not an identity relation. Again, here all the three are present, so this is an example of identity relation. It plays an important role in function. Okay, after this we will move towards function, so there we will discuss in details about the identity function which is related to identity relation. Okay, clear? Next, types of relations we have discussed. Now there are three important parts of relation. Okay, important sections, they are reflexive, symmetric and transitive. Okay, first is reflexive. A relation R in A is said to be reflexive if A is related to A. that is A belongs to R for all A belongs to A. Okay, so this is one kind of this identity relation what we have discussed now. A relation R in A is said to be reflexive if A is related to A, that is A belongs to R for all A belongs to A. Okay, so here I have written here ARA. ARA means the relation between A and A. Okay, one relation will be given, the definition of relation will be given. As per that, if AA comes under R, then that relation is said to be reflexive. Okay, let us take an example of reflexive relation. Example, let us take set A as the set of lines parallel, a set of lines parallel to each other. Okay, so let the lines are L, M, N, O, P dot dot dot, the lines. We know that a line, suppose this is a line, okay, line L. We can write L is parallel to L, isn't it? Because every line is parallel to itself, so we can write that L belongs to R. Okay, once again I am repeating, set of lines parallel to each other. Okay, so L, M, N, O, P are the line, given lines. Okay, so as we know that each line is parallel to itself, so L is parallel to L, or M is parallel to L, M, or N is parallel to N, O is parallel to O, so LL belongs to R, MM belongs to R. This is the set of lines and parallel to each other, that is the relation. Okay, defined relation. So in this case L belongs to R, so the relation R, okay, A such that A belongs to A and A is parallel to A is a reflexive relation. Okay. Now coming over to symmetric relation. Okay, symmetric relation, a relation R in A is said to be symmetric when A, R, B implies B R A. Okay, that is AB belongs to R implies BA belongs to R. Okay, let us take an example. A is the set of lines. Okay, and R the relation AB such that A B belongs to A and A is parallel to B. Okay, so here let us see, there is a line L. Okay, another line M. So if L is parallel to M or M parallel to L, both are same thing. If L is parallel to M, okay, we can say that M is also parallel to L. So L M implies A, or L M implies R, implies M and L belongs to R here. Here L M belongs to R implies M L also belongs to R. Okay, so it is a reflexive relation. But in the case of perpendicular lines, in the case of perpendicular lines, this is L, this is N. So when L is perpendicular to M implies M is also perpendicular to L. So here also we can say that perpendicular, the set of perpendicular lines defined by set of lines defined by the lines are perpendicular to each other can be a symmetric relation. Okay, so once again I am repeating, symmetric relation, a relation R in set A said to be symmetric when A B belongs to R implies B A belongs to R. Okay, so here I have given two examples, set of lines defined by two relations, one is parallel to each other and another perpendicular to each other. So in case of parallel it is symmetric, in case of perpendicular that is also symmetric. But if you think about this reflexive, this can be reflexive. Parallel lines, A parallel to B or M parallel to L, L parallel to M, L parallel to L, or M is parallel to M, both are true. So the relation of parallel lines, both symmetric and reflexive. But in case of perpendicular lines, these are perpendicular lines are not